be more interested in developing such a program apart from learning about data science itself. So let us start. So let us ask the question, what is data science? So before we answer that question, we would like to know what is data. So now the answer for that is the data can come from many systems. It can be a natural system like a human heart, or it can be like your weather or climate, or it can be like human brain, or it can be an engineering system as complex as a say launch vehicle. So you can have data coming up from all these systems. So when we ask that what is data, now the question is slightly changed nowadays. I would like to say that we say that what is not data, because whatever that comes to you in the form of a signal, or in the form of an image, or in the form of a text, or in the form of speech, everything is nothing but data. And it is about how do you view it and how you use it. So not only the data comes from systems that are already there, that is you observe the data, but you also can generate data by creating models. So basically we need to understand that the data can come both from a system that is existing already, either it can be man-made or it can be a physical system, and it can also come from models that we make in order to that these models basically depict various systems. Now, what is data science? If we want to, now after having this first information about data, that is if we know that this is what is data, and if now we want to answer the question, what exactly is data science? That is, how do we define data science? Then we can say that it is not just a tool. So people usually confuse it with just a tool or a method or a skill. So it is not just a single tool, skill or method, but it is a scientific approach where we use statistical and mathematical theories relevant to the domain of interest and algorithmic and network hardware related computer science tools in order to acquire and process big data. So big data is again another terminology. So we can say data in general and big data in particular. And it uses all types of machine learning techniques for statistical inference based on assumed mathematical model and acquired data. So now these foundations of data science is basically, it is data cleansing, intelligent data capture, and so on and so forth. So the main take home from this particular slide, what I want you to understand is that we should not confuse ourselves by seeing data science as a tool or a particular method. Rather, it is a stream of thought, I would say, or it is an emerging branch of science, or a branch of science that is identified recently.
Gopala,
yeah.
Gopala Krishnan, sorry to interrupt you. Your slides are not moving, I think. Can you make it full screen? And we are still seeing the first slide.
It is full screen. 1 second. So now are you able to view the slide data science?
Yeah. Now yeah. 7th slide we can see.
Okay.
It's possible to make it full screen.
It is full screen.
Use the presenter view is there now. In automatic down, use presenter view.
1 second.
There on the left right side. Monitors.
Automatic. Okay.
Use presenter view is down. I think you have to click that.
I have a primary monitor.
Automatic and then use presenter view.
Yes.
Try that.
Yeah, sure. Yeah, can you see this now? Full screen?
No, actually. Okay, fine. But you continue. Make sure that you are moving the next slide. Huh?
Okay.
Yeah.
Okay.
Yeah, please continue.
Okay. Yeah. So, are you able to see the next slide?
No, I think we are still seeing that 7th slide.
I'm not sure what is happening.
I think you have to do.
Just let me check up.
Yeah.
So sorry to disturb, but if you will share your complete desktop, then we can see the full screen mode.
That is if I share my desktop.
Complete desktop, sir, if you will share, then we can see the complete
Sure.
full screen mode.
Sure, I will do that. I will do that.
Okay, thank you, sir.
I will share my entire screen so that are you able to see this slide full screen?
No, Gopala Krishnan.
Oh my God.
Okay, for fine, it's fine. You can continue, but then you have to manually choose the slides. I think using your mouse.
Yeah, one second.
Pointer.
1 second.
So otherwise, can you please press F5 since you're in presentation? Press F5 so it will get in that slideshow mode.
Now what about it, Anand?
Yeah, now we can see. Thank you, Gopala Krishnan. Can you move next slide?
Yeah, are you able to?
Yeah, yes.
Fine.
Thank you.
Okay. So now we will see the formal. Yeah. So let me continue. So we will see now what are the aspects of data science. So we have seen a bigger definition. So we will see the different aspects of data science. So first aspect. So now we are actually nowadays how data science is being reinterpreted is that we are defining it as a greater data science. That means you have when we say about a greater data science, of course you can think that there is a lesser data science. Of course, yes, it is there. So this is a new terminology that is being formulated. So the greater data science includes the following aspects. The first one is data gathering, preparation, and exploration. Second one is data representation and transformation. Then the third aspect is computing with data. Then fourth aspect is data modeling, and the fifth aspect is data visualization and presentation, and the last one is science of data science. So hope all of you are able to see all the 6 components. Anand, are you able to see all the 6?
Yes,
okay.
we can.
Okay. So now usually what we do is that we identify data science as the third component because we always feel that it is computing with data, but we need to understand that it has a greater parlance and it actually encompasses all these different 6 aspects of data science, or all these 6 aspects can be combined together and called as data science. And mostly now the novel works are coming up in the last one, that is known as the science of data science, because since it is an emerging area, you talk about how do we do data science properly, how do you develop methodologies to do data science properly. So going further, why we need to study data science? So that is the question that we have to ask ourselves. So we have heard that data science is important, data science is this, it comprises of all this. So what is the necessity for studying data science? So why can't we use the traditional techniques? So I will come to that. That is, how do we contrast with what is available and what is this new paradigm called data science? Now, the most important reason why we should go for this is because we are dealing with systems which are otherwise known as complex systems. That means if you take a society, for example, the society's behavior you cannot understand by analyzing the behavior of individuals. So there exist interactions between the subunits, and these interactions are actually resulting in what are known as the emergent properties. So, and one example is, for example, if you take a single neuron of your brain, this single neuron has nothing like consciousness. But when these neurons come together, they interact with each other, we have an emergent property which is known as consciousness. So this is an example from a biological system. So earlier, the professor was talking about the stock market. So if you take a stock market, then the behavior of the stock market as a whole is completely different from tracking down the behavior of a single stock, because even if there is a crash, there are stocks which are not much affected, and even without a crash, a particular stock can just like that go, it can doom itself. So the system wherein you have individual components interacting with each other, but the tracking the system behavior is different from tracking the individual component behavior, you call such systems as complex systems. And these systems can extend both in terms of time, that is, they can be temporal systems, they develop in time, and they can also extend over space. Just like, for example, if you take a power grid, which is extended over space. So these are basically spatio-temporal systems. So these spatio-temporal systems have very interesting dynamics. So you need to understand these spatio-temporal dynamics properly. For that, the traditional techniques are not enough. Now, we will see, for example, one of the major areas in which data science is making its mark is the climate or weather prediction. That is, we all know that the monsoon prediction is an important, say, event for India or Indian subcontinent as such, and you have different monsoon prediction techniques. So we always say that there is a famous joke that we say, that is, if in the paper, if you read that today it will rain, then you do not take your umbrella. So because you know that it won't rain if it is told that it will rain. And then we also say that there is a possibility that it may or may not rain. So we make fun of the weatherman. But what is the problem in that? Actually, if you study, if some of you are aware of that particular area, then we know that from the fluid mechanical concepts, if you develop an equation, that equation is actually representing a chaotic system, and you cannot make much predictions about that particular system. It is highly difficult to make predictions, and your predictions can only be made for short-lived predictions are only possible. You cannot have a prediction window, it cannot be long, or prediction window cannot be higher than a threshold. Now, the answer for this comes from data science. So if you are observing the data such as temperature or say precipitation or humidity, and interesting thing is that you observe the temperature of some particular specific location in Afghanistan, which will let you know when the monsoon will start in central India. So this will appear like a fairy tale, this will appear like a folklore, but if we see the papers that are published, we can see that the enormous application of data science, that is, you have the computing power and you have the availability of data, because data is always available. So such complex systems, so one example is weather. Another example is my favorite example of stock market. That is, if you try to model stock market behavior, if some of you have done that, there are traditional techniques like AR modeling, AR, MA, etc. All of those models fail flat. Now, they all completely fail. They do not give you any clue about how the market works. But interesting thing is, you have enormous data present with you. That is, you take a specific stock, you know the stock indices up to this point of time from its time of inception. So why can't you make proper predictions? The answer is yes, if you are using proper tools from data science and proper techniques from data science. So this is another reason, that is the stochastic nature, so-called stochastic nature, because we always say that there is zero predictability for a stock. So in traditional classical view, we view these systems as stochastic systems. So one area wherein we apply is the complexity of the system is very high. Another area is where the stochasticity associated with the system is very high. So there also you may require this. Now going further, if you want to model a city traffic, if you want to model a city, then how do you do that? So you have classical models. So these are basically classical examples of spatio-temporal systems where the dynamics is governed by partial differential equations. So if you have complex partial differential equations, then how do you deal with it? So one way is you can model and then you can try to do it. Other way is just collect the data and then try to apply the data to make sensible predictions. And yet another example, which is of utmost relevance now, is just like this spreading of a great pandemic like COVID. So can you model, can you predict? So I am sure that all of you must have gone through several papers that predict the spread of COVID or that predict the flattening of the curve, etc. So how it happens. So this again is possible only you have the modern tools that are there from data science. Now we will see the past of data science. So is it like really data science a new subject? That is, are we talking about something that emerged very recently? The answer is no, because most of you, if you can identify this particular scientist, if you are viewing my slide, if you can identify this particular scientist, he's the famous astronomer Johannes Kepler. So, and we all studied the Kepler's law of planetary motion. So many view him as the first data scientist. So why? Because he had a lot of astronomical data, partly collected by himself and partly collected by Tycho Brahe. So using this astronomical data, he developed his 3 laws. So the famous 3 laws are already there. So I am not going to discuss those laws. So you can read them there. So these are the 3 laws that are developed by Kepler. So now, if you look at these 3 laws and how he developed it basically from the data. So he had data, astronomical data, observations, and these observations he turned into 3 laws. So at modern parlance, we can call this as data-driven modeling. So this is what now we call as data-driven modeling. That is, you have been given with enormous, you have been supplied with enormous data, then you make some pattern recognition. You understand how the system behaves from this past data or the paleo data. So that is what we call it as the data-driven modeling. So data science as such is not a new science, I would say. It was being practiced not only by Kepler, just I gave an example of Kepler, but if you take many scientists in your own area or in classical mechanics for that matter, you can see that most of them were heavily dependent, or they were relying on the data, and they were creating empirical laws which later turned into laws after observation. Okay, so now coming to the turn, or you can say the turnover in, or a turning point in data science comes when John Tuckey releases an article called The Future of Data Analysis. So he says that I'm sorry, so he is the first one to give a difference between statistics and data science. So this is still a very debatable topic. So many statisticians, I hope there are not many here, because you may not like the use of the word data science. So they say that data science is nothing but statistics, or statistics in new clothes is called data science. However, there exist differences, that is, we can see as we proceed through this particular presentation. So John Tuckey first presents this idea that just inanimmately or lifelessly going through the data is not the only thing that we can do with data, but we can develop techniques to understand more about the system that is generating the data by observing the data. So this is one major turning point in the history of data science. Later on, many scientists take up this particular viewpoint, and the term data science itself gets coined there. And if any of you are interested in reading it further, I would recommend you to go through this particular article, which is freely available, published by Journal of Computational and Graphical Statistics. The article title, as you read, it is 50 Years of Data Science, a very interesting article. If you are starting your career, or if you just want to learn about data science, this will be a good primer for you in terms of understanding the context of data science, how it developed, and how do we contrast it with the existing things. Now, if we come to the present fact of the data science, that is, if this is representing the past of the data science, if you come to the present of the data science, then you can see that data science is everywhere. For example, if you buy a book from your Amazon or whichever is your favorite e-commerce website, then you can see that immediately there is a suggestion that is coming up. That is, if you have viewed this particular book, then others have also seen, or people who bought this book have also seen these other options. Okay, so now the second thing is, like, for example, similarly you can cross compare multiple products Okay, this is very simple, so which was not possible earlier. So you can cross compare with whatever features that you want, a specific feature you can look for, and then you can cross compare any number of products that you want. Then similarly, if you go to your social networking website, whichever is your favorite, then suddenly you get a list of suggestions. They say that these are the people you may know. So basically now it is entering into your private life as well. That is, it is not just there in your professional arena or professional space, it is entering into your private life. So data science, that I would say the extending arms of data science is entering into your privacy. So now privacy it has become a debatable matter. Then similarly, if you want to travel, that is, all of us know that this is the first thing that you do if you want to travel. You go to Google and then type the destination name. So you can see that there are alternate routes that are being formulated. So all these applications, we should understand that these are all motivated by the tools and techniques of data science. Now we call all of them collectively by another beautiful name, which is known as the artificial intelligence, or we say that it is AI. So usually we can view AI and data science in this way. So AI is the outside appearance of data science, and data science is the brain of AI. So AI, you can call that systems that you make by applying the tools and techniques from data science. The whole system, you call it as an AI or an AI-based system, whereas the brain behind that system is actually data science. So if you want to become an AI expert, then the thing that you need to learn is actually data science. So that is what is going to help you in becoming a real real AI engineer or an AI scientist. Okay, so now not only that it helps you to reach there, it also tells you what are the favorite restaurants or what are the restaurants available nearby. So you can see that the amount of information that these search engines have, and how do these search engines work. If some of you are just thinking about it, it will be a worth question thinking about, and you can analyze or you can reach a point that these search engines actually work based on the basic principles of linear algebra, like similar value decomposition or rank of a matrix, etc. So it will be a worth exercise for you to go through that. So now, so the present data science is entering into the life like this, and what is happening with the advent of this particular unfortunate situation of having a pandemic. Now, what is the additional thing that is coming up? For example, now you cannot hope for human surveillance, because we know that in our country itself we are facing that problem. So you have robotic surveillance, and how do these robots work? Basically, they use the techniques or they use the modern tools of data science. So you have various surveillance techniques. Similarly, if you go to healthcare, this is one area wherein data science is invading like anything. That is, you have telemedicine, that is, you do not go to a doctor anymore because you don't have to. You have to just interact with the doctor from your house, and you have to have what is known as the wearables. So if you have a watch, the watch can even tell you how long you will live. That is, which is not actually an exaggerated statement, because if you are a data science enthusiast or if you are a healthcare enthusiast, then I am sure that you must have come across news wherein Google says that just by looking at your eye, picture of your eye, it can tell your gender, it can tell your life, it can tell your age, it can tell your average expectancy, that is life expectancy, and it can also tell about your health condition. So we should understand that we are living in a world which is completely like filled with the data. We do not even identify that whether this is a data or not, and we do not know how many people are using our data. So this may seem like a threat, but there lies a big opportunity for us, because each and every application like this is going to be more and more popular. So there is going to be, they say that there is going to be a robo everywhere, in every industry, every household, there is going to be a robo. Similarly, industry, they talk about what is known as the Industry 4 nowadays, which is a heavily data-driven industry. So it is not like the old industry wherein they are going to have only classical terminology. So it is very interesting to see that the origins of data science are closely related to what is known as the Taylorism in industry. Taylorism means you might have heard of a scientist or an industrial scientist by the name Taylor, the Taylor's two life equation or Taylor's equation, etc. So the art of quantifying everything in industry starts from that particular school of thought. So now industry is getting into data science, or data science is getting into industry by a huge amount, so that the traditional techniques are not enough. So you have assembly lines which are fully say controlled by robots. So you do not. What is the message that as educators we need to take it from here is that it is not only a particular branch, data science, that is coming up. So this is the reason why it is called as a disruptive technology. So it also affects the opportunity of many others. That is, in the sense, if you are a traditional mechanical engineer, if you are a traditional electrical engineer, if you are a traditional economist, then this particular tool or this particular technique, if you are not aware of, then your job prospects are heavily hampered. So we think in this direction, but interestingly, I would like to share some more examples. That examples are something like, if you are a lawyer, so we never think that a lawyer can be affected by something that is happening in a data science industry or in AI industry. But interestingly, we know that lawyer actually refers to the law books, and according to a particular situation, he selects a particular law and applies that. Now, what is happening is that you have this IBM Watson, so which can give you legal advice for $1 or $2. So what is going to happen? They predict that lawyers are going to lose their job by a large extent in US. That is, you are now having the AI lawyers or virtual lawyers available for you at any time. So you have something like an app in your mobile phone. So you say that now I have overspeeded my vehicle. So what should be the condition? So you tell this 1, 2, 3, reason 1, 2, 3. So you can get away from paying a fine, or you have done some crime. So how to get away with it? So this is like a very mind-boggling situation that we are into. And literature is another area in which data science is entering into. That is, you feed a system with all that of Shakespearean literature, and then now it can produce a piece of writing which will exactly appear like that of Shakespeare, so that you do not make a difference between who wrote this, whether it is written by a virtual system or not. So industry is one area, and another area, as I already told, banking, that is also getting affected. So you know that nowadays itself you are interacting not with any real people, with virtual people. So what are the technologies that are used? So you have technologies like natural language processing, which you will be seeing in this particular workshop, and again text analytics. That is, if you are applying for a loan, the banks are no more going to believe your statement. They will rather track your social media accounts, so then they can get a big picture about your financial status and your repayment status and your say behavior and character. So now that's what they say. So if your employer, if you're applying for a job, your employer is no more asking for your resume. So what you need to just share is your social media account if you are willing to. Otherwise, maybe if the employer is smart, they can hack and they can get it. Okay, so going further, again, another area that is coming up is retail marketing. So why I am saying about this is, we should understand this invading capacity of data science tools, and this makes learning data science or teaching data science very important nowadays, because now you do not want somebody to drop groceries at your doorstep because of this particular pandemic. So you will be interested in automating that process. So how do you automate? So there exists a lot of speech processing techniques. That is, I do not want all the time to write my list and give it. So instead of that, if I just call a number and say I want sugar 1 kg, and that too in vernacular tongue, need not be English. So you can see that there exist a lot of opportunities for different areas in this particular paradigm of data science. And again, people talk about drone deliveries and drones for help. So you can now see that when we say that traditional or the classical branches are going to be affected by the advent of this new disruptive technology, we should also see the potential opportunities that are awaiting for the students of such classical or conventional branches. The only thing is that you should be equipped with this knowledge of data science. So it is not a problem that if you are a mechanical engineer, but if you know data science, if you are a data science equipped mechanical engineer, or if you are a data science literate mechanical engineer, then your opportunities are much more, and you can compete with a computer science engineer, and then you can get the same opportunity, maybe because you know more about the mechanical systems than the computer science student. Now, going further, you have again in hospitality industry it comes, so you do not have any human touch. Now, future, if you think of what is going to happen in future, how the data science future is going to be, then this is a famous statement, which one of my favorite statements from a favorite author, Yuval Noah Harari. So he's a futurist, he's a historian. So if you are interested, you please read his books, very interesting books. So the idea that humans will always have a unique ability beyond the reach of non-conscious algorithm is just wishful thinking. So the future of data science is really going to be very startling. And if you are an anthropocentric personality, that is a human-centric personality, you may not like this idea. That is what is happening now, is that enormous amount of data is available, enormous amount of computing power is available. So this combination, or rather if we can call the deadly combination of enormous amount of data plus enormous computing power, this can actually result in disruptive results. So we do not know where it will end. That is, for example, you will know everything about any other person, whoever you wish to be, like whoever you want to know about. That is, if you are an employer or if you are a country. So we recently saw that a country is tracking around 35,000 or 30,000 eminent personalities. So what is the reason why they are tracking? So you can just track one's social media. You don't have to be like a super duper personality. So you have to just track the social media. That is, if you are somewhat adept in the data science techniques, if you just follow the Twitter account of a particular individual, and then if you try to get the tweets, then itself you can get to know a lot about that particular individual. So this idea that we have control over the algorithms that we are developing is no more a very practical idea. So we need to understand that that is fading away. So the future of data science is much more related with, or it is much more interconnected with future of humanity. So how we use data science. Now, another important aspect which is applicable in the local conditions is that we usually thought that we will never have systems wherein we cannot see a human being. That is, if you go to a shop or if you go to any service, then you always need that somebody should be there to receive you, somebody should be there to give you a warm welcome. Nowadays, that's what we do not want at all. So we do not want any warm welcome. So we are very happy if there are no human beings if you are visiting a particular shop. So if you are going to buy something, then you do not want anybody to be there, then you feel safe. So this is not just the case of the current pandemic. So people predict that there can be multiple problems like this in store. So this human interaction is going to go down, and we are going to depend upon systems which are mainly focusing on non-human interactions and which can give you like a human-like feel. That is, you do not understand that you are not conversing with a human being. So this is the direction in which data science is going. So they say the ABCD of future is A is referring to artificial intelligence, B is biology, so C is computing. So because biology is a repository of data, because if I want to know about you, that is not only tracking your social media, I can just track your vitals. That is, if I give you a watch, and if the watch is capable of tracking your vitals, that is enough. Or if I develop a fabric which can actually track your vitals, and if I give you a free t-shirt, then I am more than happy. If I am your employer and I am gifting you a t-shirt on a particular anniversary day or something like that, you wear it, but you do not know that the logo has a particular functionality that can track your vitals. These are all all of this will seem to us like science fiction stories, but they are no more science fiction. So the fourth one is data. So this is what they say, the ABCD of future, the artificial intelligence, biology, computing and data, and all these comprise together to what we know as data science. So data science is an umbrella view of all these. So we usually call data science, or we see data science, mostly the application part, we see it as artificial intelligence. We always say that it is AI. So, but what is behind AI is data science. Now, what are the opportunities? So the opportunities are many, as you see here. So if you are an AI or a data science engineer or an educator, so you can go from civil engineering, or you can be a biologist, or you can be a chemist, or you can be a mechanical engineer, or you can be an electrical engineer, or you can be a traditional computer science engineer, or you can be a doctor, or you can be a lawyer, or you can be a retailer, or you can be an economist. So no matter what is your profession is going to get enriched because of your knowledge in data science. And similarly, your opportunities are going to be limited if you lack this AI literacy or data science literacy. Now, having said this, I am coming to the second part and the last part of my presentation. So as educators, we also need to understand how do we develop a good data science program. That means it is now known that data science is a very pertinent branch that we should involve, or in every traditional engineering subjects, or if possible, we should start a new branch. So, or a new branch of engineering. So how do we develop such a good program? So the features of a good program, any program for that matter, there are three features. One is curriculum, the next one is pedagogy, the third one is faculty. So you should have a sound curriculum, and you should have a pedagogy that will suit to that curriculum, and you should also have faculty who can teach that particular curriculum in the way in which you want them to teach. Now, in data science, what exactly we are doing? So in data science, what we are doing is that you have some real world phenomena, you are observing this real world phenomena, and you are trying to make your own models. And then using those models, you are predicting. So I am giving you an overall picture. So data science involves this basically. So you are observing data, and you are making analysis based on that data, and you are predicting something about the real system. And depending upon the correctness or accuracy of your prediction, you will again and again refine this particular model. So for this, you require, first thing that you require is computational tools and techniques. That is, you should be very well aware of the modern or the cutting edge computational tools and techniques. Second, you should, your base in mathematics should be very strong. That means you should have a very strong base in mathematics. Third, the domain expertise cannot be ignored. That is, for example, if we are working in ECG, and if we do not know that whether ECG comes from head or heart, then no matter how good you are at mathematics, or which software that you are using in order to do your machine learning, that will not help you to arrive at any solid conclusions. So these three aspects, that is, one is computational expertise, another one is expertise in mathematics, third one is expertise in the particular domain that is chosen. All these three together will formulate a good data science program. So how can you do this? You can only arrive at this by collaborating with different departments and even across fields of science. That is, for example, if you want to develop a good healthcare technology or healthcare based application for data science, it is essential that you should collaborate with a physician. That is, it is not enough that you have only computer science people there. So it is not easy. And similarly, if you want to have a natural language processing application, text mining application, or text processing application, you should definitely have a linguist in your team. That will give you a specific advantage. Now, so the curriculum of a good data science program, you should have mathematics. This you should never forget. So this is one advice that I would like to give all the advice, or you can take it as a suggestion from my side for all those who are attending this particular FDP. There are lots of courses available in online. That is, you can see many online courses are available. But one major flaw with the online courses is that the mathematics content is very less in those courses. So if you are not good in mathematics, then you cannot develop anything of your own in data science or in AI. You can always use what is available there, but that is always limited, because unless you develop a tool for a specific application, then that will not serve many of the purposes like what is needed. Second thing, your computational tools and techniques you should be very good at, and then you should also have courses related to application. So I will just show the data science program that we have here at Amrita. So you can see that the mathematics course and computational tools, computational courses that we have here, and similarly the elective baskets that we have done. And we also have a UG program in AI itself, which we say that artificial intelligence with specialization of artificial intelligence for computer science engineering students. So there also we have similar things. Now, it is not enough for us to develop a curriculum, because you can always develop a curriculum, but it is more about how do you teach. And the plan to teach the curriculum is, we will see that. So the example is, for example, if you want to make a masala dosha, that is most of us are trying cooking because of lockdown situation. So if you ask your mother or anybody who knows how to make a masala dosha very well, maybe your wife, maybe your mother, maybe your sister, brother. Okay, so they say that you need onion, you need potato, you need oil, you need dosha batter, you need different masalas. So all that is good. So you try doing it. And what happens if you are following a bad pedagogy? So the bad pedagogy result is this. So your curriculum is good, but your pedagogy is completely flawed. So because of that, you are getting something like this. Now, if you are having a good pedagogy, so this is what the result is. So it is not enough for us to have just a curriculum. You should have a plan to teach a curriculum that is called a pedagogy. That means this pedagogy should aim at results or the evaluation methodologies that are suitable to that particular area. For example, if you are teaching data science, say, let us take an introduction to data science course, and if you are conducting a written examination, a fixed hour written examination, then there is no use in teaching that particular course, because it is not going to help the students to gain the required skills. You should have an examination with a computer. So it should be a computational examination or a computer-based examination, wherein you are actually testing their skills in analyzing the data, not just writing essays about how to do data analysis. Okay, so now just I will give you an example. So this is a differential equation. We all have studied this. So now you can solve, you can teach like this. The modeling you can teach in this way. Another way of teaching modeling is, can you model the spread of COVID-19? If you ask that question, and then if you take, for example, the number of infectious, or the people who are infected at any time is given by I, and number of people who are susceptible to that is given by S. And now, if you make a relationship between this, that is susceptible population and infectious population, you say that at any time there is some factor beta, which when multiplied will give you the number of people that will get transported from the susceptible to infectious thing. So this is what we call it as the infection rate or reproduction rate, which you have been reading through all these newspapers. So you develop a model saying that at any time the rate of increase or rate of decrease of the infectious population is equal to beta is, and that will be equal to the rate of increase or decrease of the susceptible population, because that much people are moving away from that. Now, if you do this and if you plot it, you get these curves, which are known as the flattening of the curves, etc. So you can teach the mathematical modeling essential for data science either using an example that is not at all lively, or you can take up real data. You take the COVID data of your town and ask your students to model it. So that is also another way of teaching them. So that is what is known as the good pedagogical method for teaching a program like data science. Now for that, what you need is a dedicated, committed, focused experts. That is, you cannot do without that. So that you have to keep in mind. And now what are the challenges? So the major challenge that is going to come is that there is going to be a heavy demand. So we know that whenever there is a demand for the product, so if the demand is very high, then what we will have is that we will have data science available everywhere. Everybody will start selling it. So it is not a bad thing. I'm not saying that it is a bad thing, but rather when it happens, the quality of the program will go down. So you should ask yourself, how should you distinguish yourself from the rest? Because if you want to offer this, how can you be different? Or if you want to be a data scientist, now everybody starts learning, so there is no difference. So how can you differentiate yourself from the rest? That is the question that you should ask. So you should have dedicated faculty and again you should have a pedagogy and infrastructure aimed at this, and you should have a research-oriented academic culture. So this is very important. That is, a program like data science should focus on real data. So you should collect real data from wherever possible, and then you should work with the real data. So it should not be an extension of your statistics course. That will not help to develop a good program. Or if you want to become a data scientist, you should start dealing with the data, real data. Okay. So now this is the real data science. If we say this is a real data science, and if we badly design a data science program, it becomes something like this. Then if somebody learns from there, so what they learn is this. So you can see that how mighty lion transforms to a mouse. And now what you really need is this. So you should have that confidence to do this at the end of the day. So that's what you should do. So now the last aspect that I want to tell is that when we talk about data science or the future of data science, one major thing that we need to discuss about is the ethical dilemma that a data scientist or an AI engineer will face. For example, if an AI engineer is developing an autonomous car and the autonomous car is there on its say travel, so now there are multiple situations. Situation one is that it has lost its control, there is some problem is there. So the options available for the car is that first it can hit all those 4 or 5 people there, and then it can save its owner. Second situation is just directly go and hit on an obstacle, so the owner may be harmed. Third situation may be the car may be harmed, owner may be partly harmed, etc. So we should understand that our quality of being humans is much more important now than at any other point of time. So it is, if we do not develop our skill sets to say differentiate us from the AI systems, then we will be obsolete. So for that, the 3 quotes I will share with you. That is, first thing is, it seems probable that once the machine thinking method has started, it would not take long to outstrip our feeble powers. They would be able to converse with each other to sharpen their twist. So this is to sharpen their wits. So this is already happening. If you are following the Facebook say AI research, then you know that they stopped it because 2 of their Alice and Bob started to talk with each other in a language which seemed gibberish in the beginning, but they found out that they developed a new language using the English script. So now another, so how do you deal with it? So you have to deal with it by global cooperation. Then we should move from this idea of being separate. Then we should think that we are all together. So I will close my presentation by referring to my spiritual master and our chancellor, Mata Amruthandamayi Devi. So she says that if a 10-story building catches fire and people living in the top floor are called for help, if they say that we are no more interested because it is your floor which is on fire, so you can see that how they are mistaken. So in the same way, in a world where we are going to be dominated by data and computing, we should have more interaction. We should have more place for ethics. So I would say that we should all be passion driven as far as our research is concerned, but we should also have compassion towards our fellow human beings. So I invite all of you to an exciting journey of understanding data science. I wish that this FDP will help you develop a very good understanding, and thank you all for patiently listening to this session. And I am just moving away from your lunch so that you can have your lunch peacefully.
Yeah, thank you, Gopala Krishnan. It's a very wonderful session. So we have only 10 minutes time, participants. Have any questions, you please post in a chat box. Gopala Krishnan, you can see the chat box, no?
Yeah, you can see.
Yeah.
So one question that has come is, what is the difference between data science and data analytics? So data science is, I would say it is a superset. So data analytics is just one part of data science. So as I have shown you in some of these slides, you can see that data analytics just presents one particular section on one particular hand of data science, whereas data science by itself involves data presentation, data visualization, data processing, etc. So it need not be always data analytics. And of course, it's true that it is an integration. Yeah, so data-driven modeling based on historical data, it is a very good question. That is, there are many people involved in this particular aspect now. That is now what we can see is that, for example, there are systems like very complex fluid mechanical systems wherein they just collect data, and using this data, that is usually, you know, that the modeling is done with the help of partial differential equations or differential equations in general. So instead of dealing with differential equations, nowadays we are just dealing with data. So you can create differential equations or you can create models for this. So there are many papers. So if you are interested in that, please do write to me so I can share the journals for that. Again, another question: is data science different from data mining? I would say data mining is again a single, a minor aspect of data science. In data mining, you just go there deep, understand the data, try to do something with that. So it is like a preliminary terminology that we used to have for data science, but data science is much more. Big data computing, yes, of course, big data computing is a part of data science. Yes, that is correct. So without data trails, there is no data science. Yes, of course, that is very, very correct. So data trails is a big problem that we should be very much aware of. Yes, big data is used in data science by large amount, because mostly now if you take any complex system, the data is generated every moment. For example, if you take your stock market, you cannot have structures, you cannot have platforms which can deal with this kind of data. So you need to develop big data platforms to do your analysis. Okay, so take on lack of database for physical systems. I would say that it is basically, it is there. I would say that it is depending upon the sharing mentality. That is, some industries are ready to share their practices, some are not. So that's what I understand from the question. Research areas in data science. What kind of parameter to be researching? Any research areas in data science, as I said in the beginning, practically you can do research in any area that you want if you are a data scientist. Some of the upcoming areas I would say is related to biology. So if you are looking for a research career for another 10 plus years or 20 years, I would say biology is one area. Another one is text processing, so which is like NLP, natural language processing, and speech processing. So all these areas, if you are interested, and again the traditional areas, if you are a traditional classical engineer, then still you have many areas related to that. Medical science, of course, yes. So hope, Anand, I have answered all possible questions.
Yes, Gopala Krishnan, thank you. I think one more question about the Darima and
Yeah, so again, it's a very good question. That is, what is happening in all those techniques, whatever that you have mentioned there, we assume linearity basically. We say that it is a linear time series models. However, you know that your market is not linear at all. It's a non-linear system. And more than being non-linear, it is a stochastic system as well. So you should invest more on ML and DL based techniques. So that will help more. And I will be interested in interacting with any of you if you have further questions. So I just give my official email ID here, so which you can use to contact me. So I'm just typing the official email ID in the chat box. So any one of you who would like to interact with me, either on this session or based on any of the data science topics, you are welcome to do that. Thank you all.
Yeah, thank you, participant. Thank you once again, Gopala Krishnan. It's a really eye-opening session for all of the participants. Thank you once again for joining with us. Participants, 1:25. So we'll start our session at 2:15 exactly, 2:15. So same link you can use for joining the second session. The next session is about industry perspective of data science. Thank you all once again. So Gopala Krishnan.
Thank you once again. Thank you.
Thank you.
Sir, attendance, is there attendance for this session?
No, as I said earlier, we don't have attendance activity. Actually, the activity is maintained. So who are all login in that session? So we have the log records. So using that, we are calculating the attendance. Thank you.
Oh, thank you.
So session 2 starts at what time?
2:15. Yeah.
So same link will be used for the next session?
Yes. Same link for today's session. Today, 3 sessions we are having. All 3 sessions, same link.
Okay.
So third session will be a hands-on session. I'll share you the link and code and everything. I'll share you before 2 o'clock.
Okay. So now we can leave this session.
Yes,
Okay, thank you.
yes, please.
Can we leave now? I mean, can we log out now and we can enter at 250 again? Okay.
Yes. Please log out and then enter at 250.
or 250? 215, right?
215, 215, yes. So I'm stopping the recording now, please.